Hi and welcome to video 2 for section 9.1. In this video we're just going to look at a bunch of formulas and that's really it. We'll look at one quick example of how we can implement them. But the first thing we're going to look at is algebraic operations on vectors. So the first we have as follows. If U is some vector AB and V, A1, B1, and V is A2, B2, then we get the following. U plus V, so if we just add these two vectors, this is just A1 plus A2, B1 plus B2. So if you remember in video 1, I showed you how we have that triangle. So if we just want to get from one point to the other, we can just add the two vectors. That's the difference of vectors as opposed to sides of a triangle. We can't just add sides of a triangle to get the third side. But with vectors, it's a little bit different because vectors represent displacement. That's the key to remember there. If I have U minus V, well, it's just going to be A1 minus A2, B1 minus B2. And then if I have some scalar multiplied by U, this is just C times A1 and C times B1 if I'm only dealing with my vector U. So let's look at an example of that. So if U is 2, -3, and V is -1, 2, we want to find U plus V, U minus V, and 2U minus 3V. So if you want to try those, go ahead. First two you can probably get pretty straightforward. The second one, we have that scalar multiplying both of them, then we have to take the difference. So if you want to do it yourself, go ahead and pause. Otherwise, I'll work them here. So U plus V, I'm just adding 2 minus 1, and then -3 plus 2. So that gives me 2 minus 1 is 1. -3 plus 2 is -1. So U plus V gives me the vector 1 minus 1. If I have U minus V, so this is where you have to be careful because of that minus sign. So U minus V is 2 minus a -1, so be careful there. And then 3 minus 2, -3 minus 2. So 2 minus a -1 is like 2 plus 1, which is 3. -3 minus 2 is -5. So U minus V would give us the vector 3, -5. And then the third one we have to figure out is 2U minus 3V. So first let's figure out both of these separate vectors, then we'll take the difference. So 2U gives me what? Well, I'm just going to multiply each value inside by 2. So that gives me 4 and -6. And 3V gives me what? Well, I just multiply the values inside by 3. So -3, +6. So now if I want the difference, 2U minus 3V, it's going to be 4 minus a -3, and then -6 minus 6. So if I simplify this, 4 minus a -3 is like 4 plus 3, which is 7. -6 minus 6 is -12. So 2U minus 3V gives me the vector 7, -12. Alright, so the last part of video 2 is just properties of vectors and multiplication of vectors. So first, properties of vectors, we have the following. So u plus v is the same as v plus u. So this is like 1 plus 2 is like 2 plus 1. The order doesn't matter. Same with vectors, as long as it's addition. U plus v plus w is the same as u plus v plus w. So if we have 3 of them, it doesn't matter which order we add them first and then add the last one, we get the same result. These are our addition properties. If we have some vector u and we add the 0 vector to it, we just get u. So just like with numbers, 3 plus 0 is still just 3. If I have u and I add to it its negative vector, this gets me 0. So again, like addition, if I have 3 and I add a negative 3, I get 0. For length of the vector, if I have some scalar that I multiply by the vector, it's the same as if I take the absolute value of that scalar and then multiply it by the length of that vector. So those were our addition, the reminder of our length. We looked at that one earlier. And then the last properties are multiplication properties. And again, it's much like if we're just dealing with numbers, same as with vectors. So the first one, if I have c, some scalar, and I'm multiplying it by the sum of 2 vectors, well, I can distribute. So this is the same as cu plus cv. If I have 2 scalars and I add them together, c plus d, and I multiply them by some vector, that's the same as if I multiply c times u plus d times u. Again, the distributive property works the same with vectors as it does with numbers. If I have 2 scalars that I multiply together, and then I'm multiplying it by a vector, it's the same as if I first just multiply one of the scalars and then multiply the other. And again, the order doesn't matter. So if I have c times d times the vector u, it's the same as if I multiply d times u and then multiply it by c, or if I multiply u by c and then multiply it by d at the end. And then if I have the unit vector 1 times u, it's still just u. And if I have the 0 vector and I multiply it by u, I now get the 0 vector. So again, just like with numbers, same ideas hold with multiplication. So that's it for video 2. Come on back and we'll address some more of section 9.1 in video 3.